Hi, everybody. My name's Mike Zephyr. I'm with the Faculty of Business and Economics at the University of Melbourne, where I'm an associate professor. And this is QMNET, the Quantitative Methods Network here at the University of Melbourne, which is an informal group that has managed to get some amazing speakers over the past little while here. And today we continue that with Sarah Stone and Tyler McCormick from the University of Washington's eScience Institute. And today they are going to be talking about a university-wide approach to integrative data science education and career paths. And just to tell you who we've got here today, just very briefly, Sarah Stone is the executive director of the eScience Institute at UW, which is the campus hub for data-intensive discovery, where she oversees operations and planning and designs and implements programs and partnerships. She also directs the Summer UW Data Science for Social Good program, which partners student fellows from across the country with project leads from academia, government, and the private sector to work on focused collaborative projects for societal benefit. In her complementary role as a co-executive director of the West Big Data Innovation Hub, Stone fosters cross-sector regional and national partnerships connecting data science research, education, and practice in areas such as metro data science, precision medicine, and natural resources hazards. And Tyler is an associate professor of stats and sociology at UW and is a core faculty member in the eScience Institute, as well as the Center for Stats and the Social Sciences, and a senior data science fellow at the eScience Institute, and is currently editor of the Journal of Computational and Graphical Stats, and was awarded in 2019 an NIH Director's New Innovator Award. His research covers a variety of topics in stats and data science, typically motivated by scientific questions in global health, economics, demography, and sociology. And he has, do you mind if I say this, Tyler, multiple openings for postdoctoral candidates if you go to his website through GitHub. Is that still valid, or is that
still valid? You made me nervous. Yeah, please.
Right. You say it first and then right. So thank you so much for being here. We really appreciate this, and please take it away.
Great. Well, thank you so much, Michael. And it's really our pleasure to have the opportunity to speak to you with you all today. And it's really fun actually to be able to give a talk with Tyler. I haven't seen Tyler in over a year. We're actually on opposite ends of the United States. So it's very fun to get to hang out with all of you and hang out with Tyler this afternoon, or this morning for you, I think. And special thanks to Michael and the organizers for asking us to join. And we hope that you'll keep in touch about what you're up to at QMNET and also with the Melbourne Center for Data Science. Our talk today is really going to focus on the approach that we've taken to data science education at the University of Washington, which you'll see is highly integrative. And I believe this really reflects, to some degree, the origin story of our institute, and that the programs are really tied into the creation of the institute and kind of I think the philosophy that we brought to the institute. So I'm also going to provide some of that framing, and then both Tyler and I will wrap up in talking about the creation and support of data science career paths that are, of course, necessary to support any of these data science education pieces. So this will not be news to any of you, but I'm sure you're all aware that all areas of science are experiencing a data revolution that is changing our approaches to discovery. And this data science transformation is really being driven by factors such as the advancements in high-throughput instrumentation, more powerful models producing ever more data, new modes of scalable computing, cost reductions in storage and computation, and of course, and maybe most importantly, the new breakthroughs in algorithms such as deep learning. And it's really this revolution, this revolution is really influencing all disciplinary fields, and as well as all sectors of the economy, and really many aspects of, if not all aspects of our everyday lives. And so this slide here, whoops, I'll go back, is just showing some of the projects we've been involved in across many different disciplinary spaces, going from things like neuroscience into mapping transit in and around the city of Seattle. So harnessing these advances with a coherent and intentional approach, we feel is really essential to enabling new discoveries. And so these are kind of the original motivations for the creation of the eScience Institute, was this recognition that researchers in all fields, and we really emphasize this in all fields as the approach that we've taken to data science, will need access to state-of-the-art data science methodologies and tools, and really that these tools and methodologies will need to advance rapidly, driven by the requirements of discovery. So we've sometimes talked about there being kind of a virtuous cycle between the evolution of methodologies on the data science side, which feed into new discoveries on the science application space, and those new discoveries then drive the need for new types of tools and techniques. And that what really limits this process is actually the advancement, or what really limits the advancement is actually the intellectual infrastructure. So in other words, the number of trained data science practitioners. And so that's why I think it's really important and interesting today to focus on the education programs that we're building out and also the career paths within our university. I think also an important framing for us at the eScience Institute is that data science challenges don't just emerge at the massive data level. And so really recognizing that researchers struggle with organizing and managing and analyzing and querying data in the gigabyte range, because data sets can be so complex and messy and heterogeneous, and with new instrumentation can be arriving at very high velocities. And so we really recognize the importance of engaging with the full data workflow and supporting students and researchers at every stage of this process. I remember not so much recently, but certainly early on in the Institute, we would get a lot of questions or people saying, well, I don't have big data, so I don't think this is, this Institute is for me. Like, I don't think I fit in here. And so that's one of the things we've always wanted to emphasize, that it's not like you don't need a certain size data to sort of get in the door in order to be part of the Institute. Let's see. Just for a little institutional history, I know that Melbourne is in the process or started the center last year. And so eScience has actually been around for quite a long time. So we started in 2008 with some funding in our state, Washington state budget. And then there were really two major contributions in 2013 and 2014, which allowed us to really build out our institute. And much of the structure that we'll talk about today was in the context of these major contributions, and it was those contributions allowed us to build our core staff and our core programs that then ended up in motivating the university to provide us with secure permanent funding, because we were seen as providing important services to the entire campus community. So then our mission at the eScience Institute is really about empowering researchers and students across all fields to answer fundamental questions through the use of large, complex, and noisy data. And we are a physical space on campus, although none of us have been there in over a year. But we really believed in the importance of having a physical space where we could sort of rub shoulders and overhear each other's conversations and discover that folks across very different disciplines were tackling similar methodological challenges. And so, for example, we had a group that formed around image processing that included astronomers and neuroscientists and computer scientists that were all interested in the methodological challenges with very different types of application spaces. And so our institute has a lot of different complex components and covers a broad range of activities. Obviously, we're kind of focused here today on the education piece, but I just wanted to put this slide in so that you can see the array of things that we're doing, and just to let you know that both Tyler and I are more than happy to engage and talk about some of these other aspects of what eScience does as an institute and the way we engage on campus. And I think one of the critical features to note in that regard, I've already mentioned that we have this mission to engage with researchers across all fields. And one of the things that's important about that is, as an institute, we have this kind of neutral quality. We don't belong to any particular department. And so that's really allowed us to bring together divergent players on a more level playing field. And I think that's been particularly important for us in terms of what we've been able to do in developing and helping to support the development of a formal data science education programs at the university. Okay, so today we're going to focus, or we're going to start the talk here by focusing on the formal education programs that we've helped to support at the University of Washington. But we will, towards the end of the talk, also dive into some of the informal education activities that we also host through the eScience Institute. And the formal education was really fostered, certainly initially, by the presence of a data science education working group, which brought together faculty from about 15 different departments on campus. So it was a very complex and interdisciplinary group. Okay. And so our approach to education was really centered around 3 goals. And these goals, so I've listed the first couple here. So the first goal was really the recognition that all students at the University of Washington need to get education in data science, and that many students need to learn how to use data science tools, and some need to learn how to build tools. So there's this kind of distinction between many people needing to know how to use tools, but that there's kind of a select few who are going to be interested in actually building tools. And so you'll see, especially in our graduate education program, that we make that distinction in developing 2 different types of programs. We also really took the approach that we didn't think of data science as being a discipline that was separate and sort of going to be its own department, at least not that hasn't happened to date. We really saw data science as being integrated into existing departments and units on campus. And we feel it's important that students are graduating with the data science skills that are most important and appropriate for their disciplinary field, and that departments really own data science. And so you'll see as I go into how we've developed the curriculum that the departments, both they have a framework to work within, but then they're creating and choosing the courses that are part of that framework. And so that the students in their department are really getting the classes and the skill set that they need most. And then lastly, we really, as I mentioned, going back to our mission, we have this kind of community building focus. So we're also interested in creating an interdisciplinary community of data science students. Again, recognizing that there's this value in students interacting across disciplines and talking about their work and making discoveries about tools that may have been developed in one discipline that might be applied in another space. And these sorts of activities are tied with a lot of what the eScience Institute is developing. Okay, so what does this actually look like? So at the graduate level, sort of the data science working group that I mentioned created a framework for data science curriculum. And we started at the graduate level and then moved into the undergraduate level. And the core idea of the structure of this program was that departments can offer transcriptable options to add on to their standard degree. So for example, in what I'm showing here, a student could get a PhD in oceanography with an advanced data science option. And the process for making this happen, and what it means to be transcriptable, this is probably pretty obvious, but that means it appears on the student's transcript that they got a degree in oceanography, and it actually says that they completed the data science option. And the way this works on paper is that we've created this framework and we help departments to figure out what are the how to make that, how to go through the process, I guess is the best way to say it, in their department. And then their department faculty vote to add the option. The graduate school, in the case of the graduate school, the graduate options reviews the options with input from the campus level, and then also with input from our institute. We often help departments to identify the best courses or a greater option of courses that they might not be aware of that are offered across different departments. And at the graduate level, we've developed two options. There's the advanced option, and I'll dive into these in the next slides, and then a standard option. And then there's an undergraduate option. And the process for that is similar, but as Tyler can attest, a lot more paperwork. It's a little like probably undergraduate curriculum at most universities, it's much more impacted, so it can be more challenging to push through an option at the undergraduate level. Great. So the advanced graduate data science option was really designed to be, as I mentioned before, for tool builders. And so this option includes the highest level graduate courses in stats, machine learning, database management, and data visualization. And in the case of this option, there's no flexibility on the courses, and all are required, and all of these courses require a number of different prerequisites. And the students also participate in a shared data science seminar. And again, this is a seminar that highlights work across many different disciplinary spaces, but really focuses on the methodological pieces of the work. Several departments also have additional requirements, but these are kind of the core requirements. And this advanced data science option is now offered in 13 different departments. What we realized is that the advanced data science option, because it doesn't have a lot of flexibility and it requires sort of very high level courses with prerequisites, was not accessible to a lot of graduate students. And some of the a lot of graduate students didn't really want to be the tool builders, they wanted to be tool users. And so we set about creating a standard graduate data science option where there's quite a bit more flexibility. So in the case of this option, students take 3 out of 4 core courses in methods, and they can be out of these 4 categories. So software development for data science, stats and machine learning, data management and data visualization, and or a department-specific course. And actually in each of these categories, they can select a department course to fulfill it, or they can point to courses outside of their department. Again, there's this participation in a joint seminar, a joint interdisciplinary seminar. And most of these courses have fewer prerequisites or no prerequisites. And this allows for, as I mentioned before, much greater flexibility. So if we go back to that same oceanography student who wants to do the standard data science option, then they might, for their data visualization, they might take a course in ocean modeling, right? And that would count towards this requirement. And so there's much more flexibility to take the classes that are most appropriate for the student. And I wanted to point out here that the advanced data science option actually originated in the context of a National Science Foundation IGERT training grant in data science. And you can see some of the students involved in that grant here. Around a similar time, eScience started funding postdoctoral fellows, who you also see some of our postdocs here, or former postdocs here on the left. And both of the graduate students and postdocs are dual mentored, having both a methods and a domain mentor. And they also became the first participants, kind of our guinea pigs, for a suite of community building activities, which really form this rich interdisciplinary group that convenes regularly for things like chalk talks or career workshops and social events. And the initial IGERT graduate training program that I mentioned has really served as a model for several data science related training programs in things like genome sciences, clean energy, hydrology, and actually I'll turn it over to Tyler to talk about a program focused in data science demography. Oh, you're muted, Tyler.
Of course, that's happened to me every single day for the last year and a half, and it hasn't happened today. So of course now's the time. So thanks, Sarah. So I'm going to talk about one specific example of sort of data science training, particularly for PhD students. And as Sarah mentioned, this is sort of an example of how the kind of the infrastructure and the energy that's sort of developed through eScience can kind of catalyze other types of training programs that originate from other places across campus, but are sort of in some sense inspired by and are absolutely a critical part of these programs that comes from the energy from eScience. So this is a program for graduate training in population health data science. So this is through the Demography Institute at the University of Washington, the Center for the Studies in Demography and Ecology, and it's part of an initiative by the U.S. National Institutes of Health that sort of sponsors PhD training programs. And so essentially what they do is they provide sort of 5 years of funding for cohorts of approximately 5 students. And these are sort of themed training programs. So our program is part of a program on training in advanced data analytics for behavior and social sciences. And so there's sort of 6 different universities in departments from sort of across the health sciences that are participating in a program under this sort of broad umbrella theme. And as I mentioned, our sort of theme is this idea of population health data science. So really sort of mixing the sort of the social science and demography piece with the sort of intersection of health at a sort of population scale. And so I've put the logos. I'll talk more about this on the next few slides. But one reason I think that this program is a nice illustration of the points that Sarah is making is because to come to sort of have a program like this come together, it's very hard, at least for me, sort of where I sit kind of institutionally, to imagine this happening sort of coming out of one department or even one sort of interdisciplinary institute. All 3 of the sort of the institutes that I've sort of put logos for down here at the bottom, eScience, which you've seen before, the Centers for Studies in Demography and Ecology, and the Center for Stats and Social Sciences, sort of all are incredibly interdisciplinary on their own. But I think what sort of makes this program interesting is the fact that they can all kind of come together and coalesce around this theme of sort of data analytics training in the behavioral and social sciences. And so the next slide. So this is just an overview of the other programs that are participating under this sort of broad umbrella, and sort of what the sort of flavor of the kinds of things that that other institutions are doing. And so these are all, you see some that are related. So for example, Berkeley's program is also sort of in computational social science. So in a way, kind of a bit of a broader umbrella than what we're doing. But you can also see that the way that this theme has been instantiated sort of depends substantially over the sort of range of universities. So the Stanford program, for example, has a more of a clinical bent, which isn't really part of ours, and the UCSF program is sort of focused on the idea of sort of harmonizing and integrating and visualizing sort of big data, which is sort of a part of what we're proposing, but not exactly at the sort of strength that the area of strength that we're pushing on. So on the next slide. So our program consists of a set of courses and internship experiences. And so I'll talk about the courses in just a moment, but the idea is essentially that students are spending time both taking sort of specialized courses that are at the intersection of population health and data science, and also engaging in sort of active learning opportunities. And so the idea is that students sort of rotate through these internships sort of internally and externally. And so that gives us opportunities to sort of partner with, places like eScience. Sarah mentioned some of the sort of working groups and that type of thing that are happening, that happen in eScience. Those are sort of the kinds of things that students could participate in as part of their training program. And again, sort of something that will sound familiar from other aspects of the eScience education portfolio. The notion is that all the fellows are sort of dual mentored by a faculty member who has expertise in demography or health, and someone who thinks about methodology. And so here are four of our 5 fellows. The fifth has managed to stay off the internet, which is quite a feat in 2021. But there are 5. We have students from sociology, from anthropology, and then someone from the College of the Environment. Okay, so for the next slide. So this is the way that we sort of structured the sort of course sequence for data science in data science training in demography and population health. And again, this is sort of going to reflect a theme that Sarah brought up as well, which is that we're sort of trying to tailor education activities to both enable people who are excited about using data science tools to sort of have access and to have the background necessary to sort of do that, to sort of use those tools in a thoughtful and productive way, while also trying to sort of to reach the audience of sort of tool builders or methodologists and sort of people who are trying to develop new tools. And so the idea with the population health data science training program is to sort of develop a set of courses. The first is a sort of on-ramp, which is designed more for social science or sort of other, not necessarily the sort of the most quantitative or programming intensive students to come in and get exposure to and sort of start familiarizing themselves with data science tools. And then the second course is designed intentionally to sort of be a bridge course. And the idea is to sort of have this second course be more focused around, whereas the first course is focused around sort of broad topics in sort of data science and to some extent in statistics. The second course is more focused and specialized. And the idea is that through these sort of topic areas, things like linked administrative data or sort of population level data sets, or social media data, sort of large longitudinal data like electronic health records or spatial data. The idea is that we can sort of draw in both the students who are coming from a sort of scientific perspective, who are the tool users, who've now had the first course and are familiar with some of these tools, but also draw in the sort of tool builders who are perhaps eager to engage with some of these sort of more specific topics. And so we're actually hoping to sort of get this series of courses off the ground next year. We've just finished the first year of the program, which, as you might imagine, has had some changes thanks to the pandemic, but as most other things have. But the idea is to sort of start this sequence of courses in the coming year. Next slide. And I'll just sort of finish talking about this by just sort of highlighting. I showed the sort of the three centers that are involved, and this is sort of absolutely a program that relies on the connections and the sort of foundation that's laid by this sort of cross-pollination across these centers, which is to some extent, I think, very much a part of the culture at the University of Washington, and just to sort of see how these sort of three centers fit together. We have the Center for Statistics and the Social Sciences, which is a sort of 20-year-old center, which is sort of housed with faculty co-appointed across sort of statistics and social science disciplines, and also having sort of core appointments in the center. And so this is a sort of a center that has a long history and reputation of advanced coursework in statistics that sort of focused on the social science community. There's a statistics and social science sort of track that lots of students engage in. So this is a sort of really well-established area for statistical methodology that specifically focuses towards the social sciences. And so in terms of the sort of the goals of this particular program, we kind of have this sort of base for advanced methodology, and then we can sort of build onto where those connections already exist, and then we can sort of complement that with the work that's been happening with eScience, which is as Sarah mentioned, has also been at the university for sort of well over a decade at this point, but has a broader focus than the Center for Statistics and the Social Sciences in some sense, and sort of reaches parts of campus that the center doesn't necessarily. And I mentioned that sort of the notion that's part of the goal of the program is for students to sort of have these outward facing opportunities. And so being able to sort of do things like participate in and working groups through eScience allows the students in the training program to have a much broader set of opportunities and to complement the sort of skills that they can get from the Statistics and Social Science Center. And then sort of behind, sort of the sort of core scientific aspect then comes from the Center for Studies in Demography and Ecology, which is sort of able to do, many of the sort of professionalization kind of tasks that that students will need to be able to go and sort of get productive jobs. And so, in some sense, it's this sort of confluence of things from various different parts of campus that I think has made at least the application for this training program successful, and hopefully the program itself. And so, again, I think this sort of really speaks to sort of aspects of the sort of culture around data science, and sort of hitting the sort of theme again that Sarah mentioned, that it's something that's sort of not owned by one particular place, or not something that sort of belongs to somebody, as much as I think some folks in statistics would like it to belong there, which I totally understand. But sort of we've gone a different route, and I think that sort of lets us do really interesting and productive things. Okay, the next slide. So I'll just sort of continue here and talk a little bit about undergraduate education before passing back over to Sarah. And so the first thing I'll do is talk about the data science option for majors. And so this is sort of similar to the PhD option for, but it's for undergraduates. So these options are recognized on the transcript. So it's a little bit sort of UW specific information here, but the sort of option is essentially a way that, it's a sort of way of doing a specialization or a concentration in a particular major. The next slide, please. And so this, the sort of idea for a data science option sort of came out of, again, out of the education working group through eScience. And the goal was to sort of, given that this is something that's going to be part of the curriculum within a particular department, the goal was to provide a sort of broad framework and some sense of consistency of what it means to sort of have a focus in data science if you're, a statistics major, or a focus in data science if you're a biology major, with an appreciation and understanding that, of course, those mean very different things in statistics versus in biology versus in sociology versus in astronomy. And so, so we came up with this framework, which sort of has sort of core areas in programming, machine learning, privacy, security, ethics, and society, and then allows sort of, a sort of pick 2 out of 3 from data management, visualization, and statistics and probability. And then, of course, allowing sort of optional department-specific courses. And the idea here is to sort of give some consistency or some sort of unified experience that students have when they have a concentration in data science, but to sort of acknowledge the fact that, the biology department is sort of the, is the place to go to understand sort of what it, what the sort of skills and tools are required to be a sort of, a successful data scientist in a, in the context of biology. So it's a sort of balance here by providing some guidance for what a general framework might look like, but then also allowing departments to sort of specialize in a way that makes the most sense in the discipline. Next slide, please. And so along with that, the sort of 2 other main sort of undergraduate offerings right now are sort of introductory courses sort of for pre-majors, and the sort of ideas for to try to have courses that are sort of widely appealing and that will sort of draw in students from lots of different sort of backgrounds. So sociology is taking the lead on teaching a data and society course. There's also a sort of introduction to data science course that's sort of co-taught across 3 departments: the computer science and engineering, the information school, and the stats department, as well as a Python programming course. And then we've also launched a data science minor as of fall of 2020. And next slide, please. And so, so this is new as of fall 2020. There's 100+ students that are currently declared as data science minors. and so the idea here is to sort of help students to sort of leverage familiarity with data science in fields that are outside of data science, to sort of help students gain sort of skills and fluency to work in data in their sort of major domain of study, and then also to sort of set students up to sort of be in, translator roles, to sort of have expertise in data science, but also sort of work with folks who are sort of thinking about either scientific or policy questions, and also to sort of have a sort of broad sense of, not just the sort of tools, but the implications thereof. There's currently 20 departments or units involved, and sort of eScience serves as the sort of institutional home for the data science minor. And so I'll talk a little bit more about those two last points in just a second, but I want to highlight here before I do that that one of the really things that I think is sort of really special about the data science minor is that it's designed to sort of appreciate both the sort of role of data science tools and methodologies, but also the importance of sort of context around those data science methodologies. So to sort of encourage students to sort of think about the the questions of sort of where, how the data that they're using might have arisen, and sort of how the sort of implications of the kinds of tools that they may use on the questions that they're trying to ask, and the sort of sort of broader structural, as a sort of person with a appointment in a sociology department, and the sort of broader sort of structural implications of using data science tools in this particular context. And so so we very much were working to sort of build a program that would sort of put those those aspects of data science and data science practice on equal footing with the tools, and that's actually what wound up happening. Is the sort of the program is sort of very loosely structured around these sort of two buckets, one called data skills and one called data studies. And so and sort of students are kind of picking from courses in these two sets. And again, the sort of the idea here is to engage with, in particular, students and faculty outside of the sort of traditional sort of data science domains, with an appreciation that the context and the implications of these data science methods is sort of equally important for our students to be learning about as the sort of actual tools themselves. Okay, next slide, please. Okay, and so as part of that, there's a lot of questions. I think there are a lot of questions about how we instantiate this this program, and I'm happy to talk. I can talk for a long time about those, so I won't I won't do it now. But I think it's a super important question, right? You have this sort of great new program. How's it going to work, right? How are you going to explain to the department chair in the department who's had, in the humanities department who's had a bunch of recent faculty retirements, that instead of teaching a class that they have been teaching for 20 years that they can't sort of staff, that they should instead teach a new data science class. That's a really challenging conversation to have. And I think sort of engagement with department chairs has been an absolutely critical piece of making this minor successful, because the resource constraints are real. At least they are at Washington, and it, wonderful university, everything's fantastic, but resources are finite, right? And so so this is so there's a couple of things that we've tried to do to address that, and a couple of them are on here, and I'll mention one more after I sort of discuss the sort of ones that are on the slide. The first is sort of faculty hires, which have been approved by the provost and are in progress. And so this is sort of a way to make a sort of long-term investment in the sustainability of the minor. I mentioned that there are 20 different departments that have signed on to the minor, and so signed on here means that they're allowing students to take courses in their department. there's a robust process to sort of ensure a representation of eScience in this process, the process of hiring, so that there's kind of a sense of, the department's needs, which of course are critical, but then also this sense of, kind of an outward looking, sort of perspective from eScience to make sure that, there's also some sense of, the sort of broader needs from the campus community with respect to the data science minor. So undergraduate advising has a sort of a web page, a dedicated staff person, and has sort of been active with sort of information sessions. And this is really sort of a critical piece here is this partnership with the Central Undergraduate Advising Office. So the minor, which is sort of, in contrast with the options, which are housed within a particular department, the minor is a sort of cross-campus and intentionally sort of not owned by one department. And so, so a sort of strong partnership with the Undergraduate Advising Office has been absolutely critical. And then, providing support, the sort of provost providing support through a dedicated staff person to sort of, to help both advise individual students, and then also to sort of advise advisors, both in the central office and in departments, about how to think about, how to answer questions. Like when a student comes and says, "Oh, should I take the option, in my department, or should I take the classes and get the minor? What's the advice there?" And the advice there is, that we've gone with, by the way, is if there is an option in the department, we're sort of encouraging students to do that, with the idea that, the sort of, again, the departments have this sort of sense of what the curriculum looks like for them. So the one thing that I'll mention here in terms of resources, which is the last thing I'll mention on the minor, is a sort of another way that we've tried to sort of build capacity, which is not as sustainable, but is hopefully sort of a short-term sort of catalyst type measure. And that's through a series of sort of course development opportunities. And so essentially the provost has made available a series of a pot of funds, essentially, to allow faculty members to propose courses and sort of provide protected time for course development, but then also potentially a TA or sort of an extra TA for an existing course, with the understanding that that course would then be sort of part of the data science minor. And I think, these are, we've gone through the first round of course proposals, and this is they're really fascinating. I'm happy to talk more about examples, but basically when I looked at them, I said, I want to take all of those. It's really fascinating. But sort of one thing that's sort of very interesting that sort of happened is, essentially the majority of the funds for these course proposals actually wound up going through the Center for Statistics and Social Sciences, which I think is, a sort of an example of working with the sort of the existing sort of on-campus construction, on-campus structure and infrastructure, because the Center for Statistics and Social Sciences is already sort of teaching a kind of teaching a sort of very broad set of social scientist methodologies. And so it was absolutely delightful that, that the leadership of the center was willing to sort of take on a role of sort of coordinating across the sort of social science disciplines in a way that sort of makes sense for the combined curricula of the social science disciplines, but also sort of facing towards the data science minor. And so the sort of ultimate action ended up essentially being sort of take a, rather than sort of providing, one-off kind of course support from this allocation from the provost, we ended up sort of taking a sizable chunk. I can't remember, I think it was nearly half, and sort of allocating it to the sort of social science division for them to be able to sort of, to sort of reallocate as made sense in the division, in partnership with the data science minor committee to sort of make sure that the sort of mutual needs are met. Okay, so for the next slide, so this is a sort of overview of the formal data science education programs. We've mentioned, I think the sort of the first four here, the PhD and the undergraduate options. There's also sort of professional options, sort of data science masters and professional certificates. And these are all sort of together with sort of many schools, departments, and colleges. And so So, in each of these, in each of these sort of colors and the bars within the colors, I think there's sort of lots of examples of, eScience kind of playing this, this sort of broker and facilitator role of trying to bring together sort of interested parties and sort of develop a kind of collaborative, program at all the sort of levels of formal education. Okay, so for the next slide. And so the last thing I'll mention, and I think this is, so this is the sort of taking that graphic that you saw previously and sort of turning it on the from a department perspective. So here's the departments that are participating in either the graduate or the undergraduate or both. And so what you can see is these are, you sort of have lots of the departments that you might expect, the the sort of math, stat, computer science, and that sort of thing. But we've also been able to sort of reach out to to departments like psychology, sociology, the information school, and as well as sort of science departments, like astronomy, genome sciences, geography, biology. So so I think this is this is a sort of a pretty wide-ranging set of actors here. Okay, and so I'll just finish with the next slide. Yeah, thanks, Sarah. I'll just finish with the next slide to sort of mention that an additional piece, and I kind of alluded to this before, is sort of faculty hiring. And this is sort of both in terms of thinking about sort of driving both the research and the sort of education mission, facilitation mission from eScience. And so these are data science faculty hires who are currently at the UW. And so this is the sort of rough setup here is essentially that the provost has sort of sponsored sort of half lines to sort of recruit people who would play sort of critical roles in the data science activities at UW, both in terms of the institute in particular, and also the sort of specific, also the sort of broader community. And I'm happy to talk about, these are all sort of fantastic scholars and teachers, and I'd be happy to talk more about what they work on, but maybe I'll just sort of say, a couple more brief remarks about the kinds of faculty that these folks represent, and then sort of pass back to Sarah. So for the next slide. Yeah, so the idea here is that, these are, these sort of faculty sort of bridge sort of what we're calling, in a perfect, but I think pretty good, sort of imperfect, but I think pretty good set of analogy, these sort of pie-shaped faculty. So they're kind of forming this bridge between, someone who has sort of a leg in a sort of scientific domain and one in a sort of methodology area, and is sort of working across the two. And so again, these were sort of, these are folks who are kind of essentially driving in one or both areas. And so most of them are actually driving in both areas, but they're all folks who have, who have substantial depth in both the sort of at least one domain science and methodology. And eScience participates in the sort of annual reviews of these faculties, of these faculty members, and sort of tries to advocate for alternate metrics for advancement. I can talk more about what that looks like if anybody's interested. It's something that I've thought a lot about, both in the context of eScience and in the context of the Center for Statistics and the Social Sciences, which has a slightly different model. But I think that is an important, the sort of participation in sort of annual reviews and sort of overall faculty development is a really important piece. And then I'll just sort of, the last thing I'll mention here is that, the idea with these faculty is to sort of have this sort of ripple effect across the department and the college. And I'll just mention, as an example, to kind of bring my sort of portion of the talk to the close, back where it started. So Zach Almquist was one of the faculty who was on the previous slide, who's just recently hired. He's in the sociology department and has been somebody who's played a key role in the T32 training in population health data science. So he, for example, is the person that's teaching those classes that I mentioned next year. Okay, and with that, I'll hand it back over to Sarah.
Great, thanks, Tyler. So I'm just going to spend a couple last minutes here talking about some of our informal or ad hoc types of education and training. We really recognized from early on that, we can't all go back and be undergraduates or even graduate students and get to do these options. And even, that these aren't even accessible necessarily to all graduate students. And so having other types of training programs that people can fit in the interstices of their lives is really important, and also that are tailored to particular types of needs. Knowing that, going back to Tyler's last slide, we can't all become pie-shaped individuals. And in fact, people used to joke that, well, maybe we could be more lambda-shaped, because getting those two long legs in both methods and deep in a domain field is a challenge, and it's not a reasonable expectation for all of our students or for all of us. And so we have a number of things that we've offered or developed in terms of kind of informal data science education. And some of those are listed here, and I'll talk about them in a little more detail on this slide. And again, this is something I'd be happy to dive in deeper on any of these topics if these are of interest in the Q&A. But one of the things we do is we have open office hours where people, when we're physically in a space, and you can see our space here, we have people who can just drop in and talk to any of our data and research scientists. And I'll show you our data and research scientist staff in just a minute. But they cover both a broad range of domain fields and also a diversity of different expertise in terms of their data science methodologies. We also, like you, have a seminar series that allows us to bring in both internal and external speakers, and also highlight the work of our postdoctoral fellows and graduate students. We have a number of special interest groups that span both, I would say, kind of meta-level data science topics, things like reproducible and open science, but also do deeper dives into particular methodological spaces, like thinking about things like text as data, satellite image analysis, or neuroinformatics. We run a number of different tutorials and boot camps and workshops, notably partnering with the Carpentries to offer workshops on a quarterly basis, and also offering Carpentries instructor trainings annually, so we can keep a pool and also provide the opportunity for graduate students and postdocs in particular to get trained as Carpentries instructors and get the really nice pedagogical support that comes with those trainings. We also have a very strong group of cloud compute support specialists, I guess you'd say, who can really, we run a lot of sort of Cloud 101 workshops to help people shift their research into the cloud. We've really pioneered what's called a Hack Week model, and this is quite different from a hackathon that maybe more familiar with, which tends to be more of a competitive atmosphere. The Hack Week model is really meant to foster a collaborative community. And it takes place over usually 1 week, but sometimes 2. And we've done Hack Weeks in a bunch of different disciplinary spaces, including neuroscience and oceanography, geospatial sciences, astronomy. We have some that are specific to particular satellite missions. We have one coming up that's called SnowX, that's around a satellite that is looking at snow cover. And there are a mix of sort of tutorials that are important and specific for that discipline, peer-to-peer learning, and then kind of on-site project work or hacking on projects that emerge from the group that comes to the Hack Week. And then they often have activities that continue on beyond the first event. We also do a couple short-term, kind of quarter-long research collaborations. And I didn't mention up front, but we've really tried to tailor what we do to make it sort of very easy entry, so anybody can drop in and ask a question in office hours. And we've created sort of various levels of deeper engagements. And so our Winter Incubator program and Data Science for Social Good program are 2 quarter-long engagements, because we really felt like there's kind of a missing space often in academia between these kind of asking a one-off or a two-off question and writing a proposal with somebody, which can feel like a big leap and a lot of work when you may not have the basis and the collaboration to really stand behind that. And so these quarter-long engagements allow us to engage on a kind of tractable data science challenge and work kind of one-on-one, or in the case of the Data Science for Social Good program, there's a student team that's also engaged on a data science related problem. This is also a nice way for us to engage across many different departments and kind of propagate the work that we do, because they're very much in the train the trainer model, rather than the model of kind of throwing a problem over the fence to some data scientists. And this is the team that helps us support all those activities that I just showed on the previous slide. So we're incredibly fortunate to have a research staff. And you can see here, and we put their disciplinary background just to show the diversity of people who are part of our team. And we distinguish here between data and research scientists. This is a somewhat arbitrary distinction. On our side, what that means is data scientists are people who are fully funded and hired through the eScience Institute. And research scientists are folks who are hired through other units on campus, but spend some of their time working and collaborating with eScience. And all of these folks work very readily both across disciplinary spaces and have a range of different expertise in terms of their data science methodologies. And also include folks like Anissa Tanweer, who's shown here, who's a data science ethnographer. And these are really kind of novel positions. At least I don't know if they would be considered novel in Australia, but in the United States, very novel to have these kinds of non-tenure track academic data scientist positions. The way we've structured these positions is it's a 50-50 split. So each of these researchers continues to have their own independent research programs, and they spend about 50% of their time on their own research. And many of them bring in their own. Most of our data scientists have been with us for at least 4 years, and they've started to applying for grants, and so they actually end up supporting some of their own salaries through those programs. They're really, I would say, everything that they're engaging on, because we really felt it was important to keep these positions prestigious. So even when they're, say, supporting an incubator project, the incubator projects that we choose as an institute, we only choose projects that there's a data scientist who's interested in working on. They're never in a situation where they're assigned to work on something which isn't meaningful to them or they don't want to engage in. That creates a really high, it does create this kind of high bar, but I think it really speaks to, we're in Seattle. It's a very competitive market for data scientists. And we've had the group that I just showed you, as I said, most of them have been with us for at least 4 years. And the newer folks are because we've been able to add to the team. So I think that's really a testament to this space in academia, this really important space that data scientists can fill in academia, but it's in order to make those positions desirable and competitive, there really has to be a fair amount of autonomy and independence. And that ends up, it takes some time, but that also then as they're building out their research programs, there's an opportunity for the Institute also to expand and grow with them. And I'll just go back and say, again, we focused on the education piece. We have a lot of other pieces that we didn't dive into here, but would be more than happy to do that either with questions or in future conversations. And then I just want to say thank you, and thanks for inviting us, and very, very nice to get to speak with you all.
Thank you so much. So let's go ahead and open it up for Q&A. So the way this typically works is, and it usually takes a second to get started in this format, is you feel free to put your hands up, or you can type a question. You can raise your hand, and then we can allow you to join the session, or you can type a question into the Q&A, and then we can answer it that way. So I'm happy to get started here. There was a lot there. Thank you so much. That was fantastic. A couple of things immediately come to mind. It's kind of interesting, if you look at the history of kind of related disciplines recently, and I'm thinking specifically of statistics, which before kind of the 1930s and 40s, for basically 100 years or so, they used kind of, some probability tools and census data, et cetera, starting in the 1800s. But statistics was mostly kind of a problem focused, I wouldn't even call it a set of practices. And so they would, it wasn't disciplined. And so as you see statistics emerge as a modern discipline kind of in the 30s and 40s, and it gets incorporated in many cases into math departments at universities, you see it gets funding and it becomes legitimized as its own form of study, its own field, et cetera. And it looks like kind of data science is starting to do that, but maybe a bit obviously differently than statistics did. But do you see data science becoming a department, or do you see it as being just kind of what you're describing it, or how it works at the University of Washington currently, wherein you have these links, but what you're not doing is displacing kind of pre-existing disciplines? It's kind of a difficult one to predict, I guess, because that's kind of what's going to happen next. But if we look at the trajectory, it looks like it might be headed that way.
Do you want to answer that, Tyler, or should I take it?
I was just gonna.
I would say like,
yeah.
oh, I was just gonna say, if I were to like speak somebody else's words. So Ed Lazowska, our founding director, says like we've placed our bets on it not becoming a department, and we've kind of gone that route. But I think we're all in this exploratory space where we don't really know how things are going to end up.
Right.
And it's actually really fun. That's why it's saying it'd be great to stay in touch with you, because different universities are taking different approaches, and we have this opportunity to learn what gains traction. And I think it also is likely to depend a lot on the type of university and the way the university is structured, what's really gonna work best.
Yeah.
And I'll turn it to Tyler for more detail, especially as a statistician.
Yeah, right. Well, usually other statisticians will claim me as a statistician, more or less. So that's a great question. I mean, I think there's definitely, and I think you kind of see a lot of individual places kind of moving in, I would say kind of placing bets on the other, on the other side of what we've kind of gone with at UW, as Sarah said. I mean, I think that this is slightly a sort of, slightly maybe a bit of a cynical response, but it's just so much fun to be able to kind of think about things like intellectually what data science means without having to think about the practicality of like the resource, the practicality of resources that comes with having a department.
Yeah.
And I think that's, not to say that there aren't important questions about resources with with the sort of the UW model, and that, I think we've, been, extremely sort of, fortunate to sort of have, lots of really smart and thoughtful people, including Sarah, sort of helping to sort of figure out what those, how to manage resources. So it's not to say that there's not a question there, but I just think compared to a department, yeah, it's just so much more fun to be able to kind of think about, building these bridges and sort of thinking about these cross-campus initiatives, as opposed to, we have, completely legitimate and reasonable expectations to do this with, to do X with Y resources, and we have to figure out how to do it the same way that a department does. So that's not really a prediction, but it's,
But it describes, what you're doing is answering to the extent that what you're describing the experience and of the institutional kind of context, where it exists and is evolving. And that's, I guess that's kind of what it's about. And, that relates to everything that you said, talking about, for example, retention rates, the ability to be problem focused as opposed to discipline focused, for example, which is a huge advantage that data science has, because it can be more or less agnostic. You bring something like climate change into a department of psychology. I'm an industrial and organizational psychologist by training. I don't really do that anymore, but you bring something like that, and then everything has to look like a nail because they have a hammer. And so it's got to be about individual attitudes, personality, preference, like whatever it is. And those are the conceptual tools that the disciplines are limited by. But with something like data science, you can just pick and choose, kind of substantive theories from anywhere to help your work. It seems like it's just there's so many opportunities there for problem-focused work. So we have a couple of questions here from participants, and I'm happy to read them out unless you'd like to read them yourselves, or maybe I should read them because nobody else can on the video later. So this one from Adrian. Thanks, everyone. Very interesting. I did have a question about training. How does UW handle data science training for people with limited formal mathematical backgrounds? So I did quite a bit of math in my PhD and I'm now working in data science or as a data scientist. But as I didn't have an undergraduate background in math, I found postgraduate courses in stats and data science difficult to apply for in Australia.
Yeah, I guess I would start by saying that's part of the reason that we ended up having sort of the two different options, and that we've developed, and also these distinct training programs like the one that Tyler talked about, so that we're really trying to tailor programs to the students' needs and to the backgrounds that they're bringing in, and also, as appropriate, to be able to, if there are skills that they need to pick up, to bring those in, but to bring them in, in a way that's not going to be, jumping into the highest levels, CS class, to do that. So I would say I think that's how we've tried to handle that, but that doesn't mean you get rid of the problem. There's always, that challenge of trying to meet students at the right level. And I would say I think that is most challenging for undergraduates, especially undergraduates, freshmen that are coming in and might not understand the full suite of careers that might be possible. What a data scientist might be, or a data science adjacent position might look like, and feeling really not able to engage in even something like an intro to data science class that's meant to not doesn't have any prerequisites, but just not having the right background and whatever it is in your high school, or in this case in your undergraduate, to take the next step. It's always a challenge in structuring programs.
Right.
Tyler,
To
do you
enable.
want to add to that? Oh, sorry, go ahead.
No, I was just going to say, to enable that kind of Lambda configuration that you were describing.
Yeah, the carpentries program I mentioned is a nice, at least not so much, that's not so much math focused, but a student can spend, we usually do it as 4 half days, coming and get, basic programming foundations in Python. And it's outside of the course structure. So finding things like that too, I think that's where informal education can also become really important, because it allows that sort of gap filling so that students can get the stepping stones they need, even if they're not part of the formal curriculum.
Okay, we've got another one here from Irene, and she writes, what if I'm an international student? Can I still apply for your program? It looks like you've generated a fair amount of interest here among some of the participants.
Definitely for if you're talking about graduate programs or undergraduate curriculum, those are open to international students. I don't know if Irene, if you want to write in or chime in if there's a particular program you're interested in, or just reach out to one of us and we can answer specifically for that program.
Okay, we've got another one from Raymond or Ramon. And does the Institute also educate professionals outside of the typical university course offerings? For instance, master's classes, exec education, mini credentials, etc. And if so, what have you learned in terms of structure, prerequisites, industry preferences, and price points? Might be some trade secrets there. You don't have to divulge everything.
Tyler, I don't know if you want to say that there are some professional certificate programs. There's actually a suite of them that touch on data science areas, but those are run outside. So if I had trade secrets, I would probably divulge them, because I'm not at all secretive, but but I don't have them, so I can't say much. And then there's also a new kind of executive education program that has sprouted up recently, but similarly, it's in its infancy. So I don't know that there's lessons learned to share out. Tyler, do you have anything to add there?
No, I don't. I've been kind of a little bit involved with sort of setting up a couple of those programs, but I'm pretty sure my ID has no trade secrets sort of built into the barcode. So I don't think there's,
That's funny.
If for the professional, Ramon, if you're interested, reach out and I can connect you with the folks who run those programs, though, for sure. So
yeah, absolutely. I will say, so the data science, I think that the data science master's program, I think, is sort of somewhere in between. I think there are a lot of professional students that do that, but a lot of folks that sort of go on to more grad school and stuff too. So that one in particular, yeah, I'm happy to answer questions about that. There's sort of close connections with the stat department, so I can kind of put you in touch with the right people there.
It seems like what the university is uniquely good at, you know, I mean, obviously being in Seattle, you know that a lot of kind of IT focused, you know, like Google, for example, you can get free training through Google or more or less free. And but you know, what you're offering and what universities uniquely have to offer is the ability to get some data science training along with disciplinary training. So if you want to study ecology, oceanography, psychology, sociology, et cetera, you can kind of mix and combine those things, and really no company can do that in the way that universities and specifically your eScience Institute is doing. So we have another comment, and if you want to reply or not, it just seems like somebody young has pointed out, yes, it's interesting to see whether data science will be designated as a distinct department, since it's seemingly composed of elements of stats, computer science, business, insights, analytics, et cetera. There are going to be some, for sure, probably some battles fought over that funding and otherwise, but
yeah, I would say the strongest argument I've heard for this is particularly around graduate degrees in data science, but I think it applies to a department, is there's an opportunity in creating a new department or a new sort of disciplinary space to sort of start from scratch in terms of the kind of diversity and the environment that you're creating. And computer science isn't necessarily known for you know, as the most the most inclusive place. And so I think that's one of the arguments I've heard, that there's kind of an opportunity, as you know, in creating the field of data science to really and I think we're certainly seeing that in the call for people to be using, you know, data science responsibly and ethically. And so maybe there really is an opportunity in that space to really define and take advantage of the newness, and that it doesn't have some of, you know, the baggage that we all carry around in old departments. Not that computer science is that old, but yeah.
Right. Well, maybe we should stop there. Thank you so much. And I forgot to mention, I'm sure Kirsten noticed, to mention in the beginning that yes, the University of Melbourne has its own Melbourne Center for Data Science, which Sarah, you noted, and they've kind of co-sponsored this here today and helped us organize. And so if you're interested in data science, you've got a great resource there, and you've got a great website too, the eScience Institute. And if you're local, you can come check us out here at the University of Melbourne. And thank you so much. That was fabulous. It's such a cool thing, and we hope to chat with you soon.
Thanks very much. We appreciate the chance to be here.
Yeah, yeah, thank you very much. And we would love to actually get to be there, because I've never been to Australia, so that's definitely on my list.
Okay, great. You're invited.
Okay.
You're invited.
Yes, you're invited.
Great, thanks.